वेलकम टू अबरार इलेक्ट्रिकल वर्ल्ड, अबरार इलेक्ट्रिकल यूट्यूब चैनल. पहले we had name of Abrar Electrical World. Now we call it Abrar Electrical only. So if you search Abrar Electrical on YouTube, you can find our video lectures about electrical engineering and electrician licensing exam in Canada. So if you want to attend a complete course, then you can always send a email on this address given here, tdconsultant.global@gmail.com. So this video is about determining the ampacity and using the Canadian Electric Code 2021, which is the latest one at the moment because they publish it every 3 years, and this is the latest at the moment. So let's move forward and we will see that how we use rule number 4-004. So let's go. Now see, this is the section 4 conductors of Canadian Electric Code 2021, section 4, and we have shown here the exactly what is the scope of this section 4. You can see here the determination of maximum allowable conductor ampacity, determination of maximum conductor termination temperature, selection of neutral conductor, the selection of conductor type, and then conductor identification. So we will take up almost all the subjects from the Canadian Code to prepare you for the licensing exam. Now this video lecture is about the part 1A, that is determination of maximum allowable conductor capacity. So let's see what is the rule. Now this is the rule 4002 about the size of conductor, and here you can see that it is written here that except for flexible cord equipment, wire, control circuit, insulated conductors and cable, insulated conductors shall not be smaller than 14 AWG when made of copper and not smaller than number 12 AWG when made of aluminum. So this is a kind of a note here, and we now move to 4-004, which is about the ampacity of wire and cables, and it is sub-rule number 1A and B, which is applicable to copper conductors. And the table 1 and 2 also relate to copper conductors. So we will also go to the table 1 and 2, and we will take some examples and calculations also with the help of these table and the rules. And by the way, the table 3 and 4 are about aluminum conductors. So we may not be considering table 3, 4 while we are using the copper cables. Now, here are the tables which we are going to use in this video lecture: table 1, table 2, and table 5C. Table 5C is about the correction factor when you have more than 3 conductors. So ultimately, we will have different examples where we apply table 1 and then another example using table 1 and 2, and then another example using the table 5C as well. Now see, here is the example, and 1, 2, 3 examples are shown here. Determine ampacity of one number copper 2 AWG RW75. Now this is about the one number of copper wire, and the size is 2 AWG. Sometimes they call it also AUG. Electrician call it AUG, to 2AWG AUG, and then RW75. Now the 75 indicate the allowable temperature of the insulation on the wire. So this is about the temperature which controls the ampere rating. Now here I have written that go to table 1, so I will show you the table 1. See, this is the actual table from 2021 Canadian Electric Code, and see here the allowable temperature for single copper conductor, bare, covered or insulated, rated not more than 5000 volt. So I have considered here the temperature not more than, but we have considered here only 600 volt wire, which is residential wire, residential settings, not a high voltage. So I will check from here that what is the rating for our size. What was our size? Let's see again. It was 2 AWG. So you see here for 2 AWG, you can see here for 2 AWG, the current rating at 75 degree is 170 ampere. So this is it for this. If you have one copper wire and size is given, RW75 is given, so you can go to table 1 and you can find out the value of that cable, allowable capacity of the cable or the wire. Now, the question 2 is determine ampacity of each wire when 3 wires of 2 AWG, same RW75. If you have more than, if you have up to 3 wires here, then you will have to go to another table, which is table 2. See here it is written the single copper conductor. So this is not applicable here. We will go to table 2. And by practice, ultimately, you will remember where to go. Now, see here, this is the table 2, and here it is written for not more than 3. So we have just 3, and we don't have more than 3. So again, we will go to here this size 2 AWG and 75 degree, and you will find here the current rating. Let's see again what was our values available. We had 2 AWG RW75. So let's see here 75 degree, and you see here 2 AWG and 75, it 115 ampere here. So this is our ampacity, and very simply you can find out using the table 2. Why we use table 2? Because table 1 is for one conductor only, and table 2 is for 1, 2, 3 conductors, not more than 3 conductors. Now another question, determine ampacity for each conductor with 6 AWG copper wire RW75 in one conduit or something. Okay, so what will we do? First of all, because it is 6, so we will go for more than 3. We will go to 3 and then we will apply the correction factor. So in T2, you see T2, you see for this size of paper, which is 12 number, you can see here 12 number, and the rating is for 75 degree. RW 75 means that this column here. So you come from this side, which is the size given here. So we have which number I have here? Let me check again. 12 AWG. So I will check the line 12 AWG, 12 AWG, and I reach here 25 ampere. Now this is for up to 3. So what about when we have 6? Then for that matter, we will have to go table 5C, and where we will take the correction factor and apply on this. So I will show you exactly the table 5C here. See, this is applicable to rule 4004 and table 2 and 3. See here, you must check because there are other tables also which are not applicable to your case, because we have used table 2, and it is also applicable to table 4. So table 4 is for aluminum, but we have already used table 2. So this is a valid table for us for finding out the correction factor or the derating factor. We also call it the derating factor of the conductor. So we have the 6. So we will use here this one, this line, that 0.8 is the multiplication factor. And see, I have multiplied this by 0.8, and the final rating is 20 ampere. So this way we calculate the ampacity. I have shown you with the 3 example using the tables 1, 2, and table 5C, and it is from the Canadian Electric Code CEC 2021, the latest one. So if you are interested in doing some kind of course with us, you can always send us the email on this one, and we will send you the related information. So this course, electrician course, industrial electrician, power system operator, it's a certification course conducted by all the states or the provinces in Canada. And through this, the advantage is that if you are a electrician or some electrical field anywhere in Pakistan, India, Bangladesh, anywhere in the world, and you have a qualification for the examination, which we have explained in different video lectures. But this is a technical lecture, so we are not discussing there. But this is a course which makes you qualified for the examination or certification of the any kind of electrician and practicing as electrician and becoming the electrical contractor ultimately. So thank you very much. This is all for this video. Please subscribe this. Please share this, because this is for the advantage of the young electricians, BTechs, polytechnic diploma holders, and even the 12th class pass who are electrician, and they can read and write a little English. And remember, there is no requirement of IELTS for this kind of examination. So thank you very much. See you again with another video where we will discuss the ampacity, how to find out the ampacity, where the conductor temperatures are different, like RW90 is with the RW75 in the same conduit. So that will be a different lecture. Thank you very much.